Today I shall discuss a problem on impulse turbine, impulse steam turbine. The problem is given: steam enters the plate at the turbine at 300 meter per second when the nozzle angle is 20 degree. The diameter of the turbine is 100 centimeter and it rotates at 3000 rpm. The blades are equiangular. If the friction loss is 35% of kinetic energy corresponding to relative velocity at inlet, find the power developed by the turbine. The axial thrust is 150 Newton. This is the problem. Now I am going through this problem. Before that, we have to find the values given for this problem, the datas. Here given datas are: the turbine steam enters the blade at the turbine at 300 meter per second. So this value is V1, which is 300 meter per second. The nozzle angle is alpha, which is 20 degree. The diameter of the turbine, which is given 100 centimeter, that is 1 meter. The speed of the turbine, the diameter is given, diameter is this. The speed of the turbine is given, that is N equals to 3000 rpm. The blades are equiangular. That means the inlet and outlet angle of the blade are same, that is theta equals to phi. If the friction loss is 35% of kinetic energy corresponding to the relative velocity of the inlet. Friction loss. What is friction loss? That is VR1 whole square minus VR2 whole square by 2. This is the friction loss. This equals to, it says that this equals to 35%, that is 0.35 of kinetic energy of relative velocity, that is at the inlet. So relative velocity at the inlet, that is VR1 square by 2. This is the kinetic energy. This is the kinetic energy corresponding to the relative velocity. Relative velocity. This VR1 is the relative velocity at the inlet. So the inlet kinetic energy is VR1 square by 2. Okay. Another is given, the find the power developed. We have to find the power. Okay. The axial thrust. What is axial thrust? V m dot s Vf1 minus Vf2. This is the axial thrust, which is 150. It's given. Now go to this problem. First of all, we have to draw the velocity diagram. The velocity diagram is like that. Okay, now this is VB. You have to find this VB first. VB equals to pi dn by 60, that is 3.14. The diameter is given 1 meter and n is 3000 divided by 60. That's will come, that's value will come 157 meter per second. So this is 157, this VB. Now this is V1, this is VR1, this is VR2, this is V2, this is VF1, this line is VF1, and this distance, this A, this is B, this is C, and this is D. So this distance is VW1. A to C, this is VW1. Now this V1 is given 300 meter per second. It's given 300 meter per second, and we got this VB is 157. Now this angle is given 20 degree. This is alpha 20 degree, and this is theta, which is equals to phi. Given theta equals to phi. Now we have to find this. We have to find this theta first. To find this theta, we have to find AB first. AB is V1 cos 20 degree minus VB, that is 300 cos 20 degree minus 157. This value is 124.907. Now find VF1. This value is this is 300 sine 20 degree. This value will come 102.606. Okay. Now, what is theta? Therefore, theta equals to tan inverse VF1 by AB. So this is tan inverse 102.606 divided by 124.907. This value will come 39.385 degree. Okay. Next, from this we have to find VR1. VR1. This value VR1. VR1 is VF1 by sine theta. This value will come, VF1 is 102.606 and this is 124. This value is sine theta is 39.385. This value will come 161.704. Now it's given this VR1 square minus VR2 square by 2 equals to 0.35 VR1 square by 2. From this equation we can find this VR2. So we can move from this inlet triangle to the outlet triangle. This is inlet triangle. We can go to the outlet triangle. Okay. Now we have to find VR2. For this VR2 we have to use this equation. Now it given VR1 square minus VR1 square minus VR2 square by 2 equals to 0.35 VR1 square by 2. If we put the values of VR1 here, we got 161.704 whole square minus VR2 square by, obviously this will go. Now this equals to 0.35 into 161.704 whole square. From this we can find VR2 equals to 130.37. So now we have to find the power. In the power formula of the power, mass of the steam is required. So we have, first of all we have to find the mass of the steam. Before that we got the VR2 value of VR2. Now we have to find this value VF2. How we can find VF2? This VF2 equals to VR2 sine theta. Theta equals to phi, it is given, or you can write phi. From this triangle we can find VF2. So we can put this value 130.37 sine phi equals to theta, that is 39.385 degree. This value will come 82.723. Now use the axial thrust formula. The axial thrust equals to m dot s Vf1 minus Vf2 equals to given 150. This is given. Now from this equation we can find m dot s. This Vf1 already you have find. This Vf1 is 102.606. 102.606 minus Vf2. Vf2 is 82.723. This equals to given 150. So we can calculate and find this m dot s. This value we can calculate, and this is 7.544 kg. Now use this m dot s into the formula of power. Power is m dot s Vw1 plus Vw2 into Vb. We know Vb m dot s, but we have to find Vw1 plus Vw2 and Vw2. So you know this Vw1 equals to, you can find this from this. It is easy to find that Vw1 is the V1 cos 20 degree. So you can write V1 cos 20 degree, and Vw2 equals to Vr2 cos phi minus Bc, that is Vb, which is 157. Vr2 cos phi, that is B2D, and Bc is 157. So we know this is Vw2, and this Vw2 is CD. This is, you can write this CD, which is BD minus BC. What is BD? BD is Vr2 cos phi, and BC is 157. Can calculate. Vr2 is 130.37. Cos phi is theta, and this theta value is 39.385 minus 157. So by this calculation we can find this value is minus 56.237, and this value will come, this is 281.907. Okay. Now put this equation, power equals to m dot s is 7.544 into Vw1 is 281.907 minus 5 can write this way, minus 56.237 this into VB. VB is 157. So by this calculation we can write this value will be 266.946 or 266,946 watt. This equals to 266.9 kilowatt.